Good evening. I'm Spot On Weather meteorologist Matthew Euler, and welcome to tonight's Teleconnections discussion for 2 December 2022. Hoping that everyone is getting into that holiday spirit. Here's some ornaments, typical Christmas colors of green and red tonight with some Christmas lights in the background. So hopefully, you're getting out there and maybe doing some outdoor decorating or perhaps decorating the indoors of your homes, putting up that Christmas tree. It's a very festive time of the year indeed. We've got a lot to talk about tonight in the teleconnections discussion. There's a lot of moving parts. So let's get right into it. Before I do that, I'll go ahead and jump in with the laser pointer here. Okay, now we're ready to roll. All right. So first, let's take a look at the 500 millibar height anomalies for the 2nd of December, this Friday, the 2nd of December, 2022. And really what I'm focusing in on is the Northern Hemisphere areas, okay? And so I'm going to brief the Northern Hemisphere working my way from west to east or left to right, again focused up here on the upper portion of this particular graphic. Now this, by the way, is the European Ensemble. This was the analysis for today as of 00Z. All right. So first, starting things off, we see an upper level trough, which is extending from northeastern Siberia, working southward towards China. Downstream of that shortwave trough, we see height rises associated with this fairly strong upper level ridge, which is generally working its way, extending its way northward into the Bering Sea, as well as into the western portion of Alaska. Downstream of that very strong ridge there into Alaska and the Bering Sea, we see troughing once again, which is occurring over the far northeastern Pacific, just off the coast, the west coast of Canada. And that trough extends all the way down from Washington State, Oregon to Northern California, the northwestern U.S. basically. With an upper level ridge then showing up downstream from that western trough, we're seeing a 588 decameter high height center over the Gulf of Mexico. And we see ridging extending northward from that high height center right on up into the Midwestern U.S. We also see some weak ridging extending up the eastern seaboard. And then as we look a little bit further to the northeast from this ridging from the Gulf of Mexico, we see another shortwave trough here at 500 millibars, extending from generally covering parts of eastern Canada. And downstream from that, over the North Atlantic, we have a significant feature here that is currently an upper level ridge, which is extending northward into southern Greenland. Now, this is going to be a big player in tonight's teleconnections discussion, associated with what's known as that negative North Atlantic oscillation, or negative NAO. And then, working our way further east, we see an upper level trough, which is located over the eastern North Atlantic, well to the west of Portugal and Spain, or to the northwest of Portugal and Spain. And then there's another major upper level ridge, generally located extending northward into the higher latitudes north of Norway, Sweden, and Finland, extending way up here. Now, by the way, if you look at these numbers here on the vertical bar, this shows you the height anomalies in meters. So the lighter the brown coloring and the white, that indicates anomalously a very strong upper level heights, a very high heights, anomalously high heights. So just want to point that out. Where you see the blue coloring, that indicates your anomalously lower heights. So overall, let's take a look at this current picture and just kind of summarize it here. We currently have 3 highly amplified upper level ridges across the northern hemisphere. Okay, we have this one here into the Bering Sea, just off the west coast of North America. We've got this one extending over the North Atlantic towards southern Greenland. And then we have the strongest one there, again, north of the Norway, Sweden, and Finland area. So there's 3 specific highly amplified upper level ridges, or higher height centers. And then we see 2 main deep upper level troughs. We have one that's situated over northeastern Siberia in Russia. And then we have another one over western North America. Okay? So that's what's going on right now. Now let's move on to a discussion on the Madden-Julian oscillation, the phases and the areas of enhanced convection. Just again as a refresher, we see the MJO basically divided up into 8 phases, from phase 1 all the way up to phase 8. And where you see these numbers, that's generally where we would see enhanced rising vertical air motion or enhanced convection or enhanced precipitation and cloudiness, generally associated with these various MJO phases. So for example, if I have a lot of convection going on over the Indian Ocean, I would be looking at MJO phases 2 and 3 perhaps. Well, if I'm looking at the maritime continent and I see a lot of upward vertical motion and thunderstorms and showers and unsettled weather in the deep tropics over the maritime continent, we would be talking about phases 4 and 5. If we talk about convection, rising vertical air motion, some thunderstorm activity here, showers and storms in the deep tropics across the western Pacific, we would be talking about phases 6 and 7. And then there's phase 8, which is closer to the 180-degree longitude line, the international date line. One of the more favorable MJO phases during a La Nina winter is going to be right here at phases 6 and 7, okay? And that's mainly due to the warmer than normal sea surface temperatures over this part of the world. And whenever you have warmer than normal sea surface temperatures, it generally tends to promote rising vertical air motion, clouds, and precipitation. But the big thing here, the big takeaway is the tropics, specifically the equatorial Pacific Ocean, definitely has a say in what happens all the way over here where we live here in the United States in the mid-latitudes. It provides that abundant energy, heat energy, which drives the world's atmospheric, oceanic, as you know, those circulation patterns. All right, so let's take a look before we get into the specific forecast for the MJO. We'll look at the infrared satellite imagery for the 2nd of December 2022. Infrared imagery, what am I looking at here? I'm looking at measuring cloud temperatures. So the higher or the colder the cloud temperatures are, the brighter the clouds appear on IR satellite imagery. And usually when we talk about colder cloud temperatures, that generally indicates that we have some pretty significant vertical air motion, and that is typically associated then with precipitation. So I'm looking here at these brighter areas, these brighter splotches of clouds on the infrared imagery. If I look at the little gray areas here, these little speckled clouds, very gray, dull gray appearance, that indicates warmer or lower clouds. So we've got higher clouds, colder clouds here with the brighter colors, bright white colors, and then we have the dull gray colors representing warmer, lower clouds, okay? All right, so this is the IR image for today, the 2nd of December 2022. We're looking at the Western Pacific. Here are the Marianas Islands here. Geographically, here is the Philippines. There's Taiwan. This is the coast of China. This is Japan up here. And so what are we looking at here? Generally, we're looking at the most active convection focused over the Western Pacific west of the Philippines. And this really hasn't changed much since the last Teleconnections discussion video I did back on the 18th of November, about 2 weeks ago. So we still see the focus of convection and the rising vertical air motion over here in the South China Sea, west of the Philippines. I do see a few more clusters of storms here, unsettled weather south of 20 degrees north latitude, generally well to the east of the Marianas Islands, well to the east of Guam. And then we see this frontal boundary here, this frontal zone just extending northeast to southwest, around 30 degrees north on up to 40 degrees north latitude, just off the coast southeast of Japan. One thing we don't see, because we don't really have this put in motion or animated, is there is a decaying wave of low pressure in this area here. Okay. Looking at the Indian Ocean on the right, we see a lot of upward vertical motion. These brighter colors, again, infrared imagery. We have colder cloud tops generally associated with these clouds, the brighter white clouds here. And we have convection rising air motion generally across Indonesia overall. Now, let's look at the forecast. But before I get to the MJO forecast, let's take a look at the temperature composites for the months of December, January, and February. We talk about the specific MJO phases 1 through 8. All right, so in general, what we're looking at here, across the eastern U.S., if you live in the east and you like colder, wintry weather, you're generally going to be rooting for a phase 8, phase 1, or phase 2 MJO. If you like mild temperatures in the east, you're going to really root for that MJO phase 4, 5, 6, and even 7 is somewhat mild. Okay, So this is what the composites look like from December through February, the winter months, the meteorological winter months, and these do change throughout the year. The temperature composites will not be the same, okay, in different times of the year. General, again, just to describe this, what we're looking at here is blue coloring indicates below normal temps, and then the orange coloring is above normal temperatures. All right, so let's take a look at the forecast here on the right. We're looking at the GFS Ensemble forecasting system on the right. This is the latest run as of today, the 2nd of December, and it goes out to the 16th of December, so just beyond mid-December. What we're looking at right now is this green line here. I pay attention to this green line because this represents my ensemble mean, or my ensemble average of all the different members that make up this particular model. All these yellow lines are different potential outcomes in the ensemble forecasting system. The green line is kind of like that down the middle center point average of all the yellow lines here. So what we're looking at for the GFS ensemble forecast is we're now heading into the null phase. Anytime we have this green ensemble mean line and even these yellow lines, when they're all scrambled up within this small inner circle, that basically means that MJO is not favored in any particular of these phases. None of these phases MJO is favored in, and it's generally considered a null phase with minimum impact. So as you can see here, you know, the thicker green line represents week 1, the thinner green line week 2. It tries to kind of rotate up around closer, you know, getting closer to the edge of the null phase to phases 6 and 7. But in general, it's pretty much in the null phase to the 16th of December. Looking at the GFS operational MJO forecast here on the left, we're looking at the aqua color line here, generally showing a similar outcome for the forecast of the 16th of December, generally remaining within the small inner circle, indicating minimal impacts to the null phase. Looking at the European extended outlook, now this was actually run yesterday, the 1st of December, and goes all the way out 30 days, all the way out to the 1st of January, to the new year. Generally what we're looking at is very similar, okay? You can see all these lines, these yellow lines, all the different ensemble, or all the potential solutions or model members. Generally what we're looking at is European extended showing MJO in the null phase as well. And then over here on the far right, we have CFS forecast, a climate forecast system, kind of showing a loop here. Generally, this one's weekly in phase 8 and 1 before rotating into the null phase. All right, so the bottom line, the majority of these models for the MJO forecast are pretty much predicting a null phase or minimal impacts expected from the MJO on the general upper air pattern as well as the U.S. weather. At least through most of December, at least up to the 16th of December, potentially, according to this European, even further out in time to the 1st of January. Now let's take a look at the sea surface temperature anomalies. What are we looking at here? Blue coloring indicates below normal water temperatures. Oranges, these light oranges and these brighter oranges represent above normal water temperatures. So what do we got going on here today on the 2nd of December, 2022? Well, you'll notice this little area here across the eastern portions of the equatorial Pacific as well as the central portions of the equatorial Pacific. This is associated with the current ongoing La Nina event. We see above average temperatures generally located over the northwestern Pacific, over just south of the western Aleutians, extending back westward a little bit to just northeast of Japan. And then we do see some above normal waters over the western Atlantic as well, off the east coast of the U.S. One thing I did note, and I did some comparisons on this, this is today's, but I look back to the Teleconnections discussion just 2 weeks ago, and we had so much brighter orange coloring north of 30 degrees north latitude in both the North Pacific and the North Atlantic. Definitely looks like, those storms are really mixing up the water in recent weeks. The storm track is getting more active across, that polar front area, the 60-degree latitude area, where the polar easterlies and those mid-latitude westerlies converge. And so whenever you get a lot of storm activity over these locations, it tends to mix the waves. The wind tends to transfer its energy to the waves, and those waves really get rough, and that mixes the temperature profile up a bit. So in general, we're definitely seeing a cooling trend to some of the northern latitude ocean water temperatures in the recent 2 weeks. Looking at the latest La Nina update, this is the latest value. This is courtesy of Levi Cohen at tropicaltidbits.com. So right now we're at 1.04 degrees Celsius below normal water temperatures in that Nino 3.4 region. This equates to that lower end moderate La Nina. Now, I have been watching this closely. There's been times where, like after November 18th here, the blue line representing the changes in the sea surface temperatures, you'll notice a little bit of an uptick in it, right? Here, by the way, is the scale on the y-axis of the temperature anomalies in degrees Celsius over here on the left. But you'll notice a little bit of a rising or warming type of situation with the water temperatures in Nino 3.4 region. And just literally within the last 48 hours, the water temperatures cooled again in the Nino 3.4 region to just below that -1 degree Celsius departure from normal. But it got as warm as about minus 0.88 degrees Celsius earlier this week. Looking at the intensity classifications, generally these, by the way, in the upper right are the different regions within the equatorial, eastern, and central Pacific. As far as comparisons of water temperatures, whether we're talking the Nino 1+2 area, the Nino 3 area, the Nino 3.4 area, which is the one that NOAA uses to classify the strength of the La Nina or if a La Nina is occurring, and then in the Nino 4 region is further westward. These are the latitude, longitude. This is the bounded box, the longitude for the Nino 3.4 region. And then, by the way, here are your categories again, or classifications of the strength of La Ninas, the intensity classifications, weak, moderate, as well as strong. Okay, so right now, remember, we're sitting at minus 1.04 degrees Celsius, so we're just into the lower end of the moderate territory of La Nina right now, but it does fluctuate between that lower end moderate to the higher end weak La Nina classification. Now, what about the history of La Nina? Okay, what about the history over time? Yeah, this is from the Climate Prediction Center, from the NOAA Climate Prediction Center website. All right, anytime you see blue boxes, that indicates La Nina conditions. Anytime you see the red boxes, it indicates El Nino conditions. Anytime you see this lighter gray coloring, or rather darker gray coloring, that's indicative of ENSO neutral conditions, neither La Nina nor El Nino. So if we go back to December 2010, and the reason I mentioned 2010 is because of the upper level pattern over the North Atlantic is very similar to December 2010 when it was pretty cold across the eastern U.S. I wanted to show you for the months of November, December, and January that a Nino 3.4 water temperature departure was 1.6 degrees Celsius below normal. And then when you got into December, January, February, you're starting to see a weakening trend throughout the winter of 2010, 2011. But in general, the water temperature anomalies were a little bit greater than what they are today is what I'm getting at. All right, but we did have La Nina in that infamous December 2010 month where we had a very strongly negative NAO, and I'll get into that NAO stuff here in a bit. Generally, what we're looking at here are the models in the upper right, just generally showing you the various model projections of the La Nina, and you notice how the lines are generally trending upward towards this zero line to where there's no departure from normal in those water temperatures in the Nino 3.4 region. So we have a warming profile to the water temperature departures. That is going to be indicative of a weakening La Nina as we progress through the late winter season. And then down here in the bottom right, this is pretty much a repeat from my last Teleconnections discussion. It's not been updated yet. This was the one issued last month in November, but the blue vertical bars indicating the probability of La Nina conditions, very high initially, generally a 76% chance of a La Nina for the December through February time period. And then you'll notice gradual weakening. See this vertical blue bar, how it gets shorter and shorter over time. So by the time we get to February, March, and April, we're looking at ENSO neutral conditions. There's a higher probability of ENSO neutral over La Nina conditions by February, March, and April time period. And then definitely we're ENSO neutral through the summer, or through the spring and through the summer. And then you start to see this red line start to grow, this vertical red bar line start to grow, and that's indicative of El Nino. So, well, we are expecting some warming as of right now per the latest projections for late next summer. Now, let's take a look at some of the Teleconnections forecast, and we have some interesting things to talk about tonight. Arctic Oscillation forecast. Here are your differences in the way the atmospheric circulation sets up during a negative Arctic oscillation on the left and a positive Arctic oscillation on the right. One thing to keep in mind here with a negative AO is typically leads to more cross-polar flow. You generally have Arctic air which spills from the Siberia area, works its way all the way down into the Canada and the US, much colder air. We see cold air all the way to the East Coast with a negative AO. You have milder, warmer temperatures along the West Coast of North America. And also with a negative AO, you get East Pacific ridge is stronger and more persistent. And then over here on the right is a positive AO. And now the Arctic air and the lower pressures and lower heights are bottled up to the far north over the North Pole with a positive AO. And so this Arctic air is generally going to remain over the polar areas and not readily move southward into Canada and the US from the Arctic. You're going to have more of a west to east jet stream with a positive AO. Okay, you have a stronger polar vortex. North Atlantic subtropical ridge is going to be stronger. It's going to be positioned further north. And there you go. And you have more troughing, by the way, over the Aleutian area there in the Gulf of Alaska with a positive AO. So let's take a look at the AO forecast now. European model. What are we looking at? Negative AO forecast. We're sitting here on the 2nd of December. You kind of see it comes up just a slight bit, but then it drops off pretty sharply to negative right on through the end of this particular model run, 13 December, negative AO according to the European. European EPS, 50 perturbed members. That means I have 50 different model members in this ensemble model run, showing the green line indicating the ensemble mean of all the model members. And look at this. Look at how negative the AO is going to be. And it's going to remain so all the way through 17 December. European EPS AO 50 perturbed members, 40. Now this is the 46-day forecast here. Okay, so we looked at the 50 perturbed members 15-day forecast. Now we're looking at the European EPS 50 perturbed members 46-day forecast going all the way out to mid-January. And look at this. Look how long the AO is negative all the way up into early January before becoming neutral. And you really don't see a very sharp rise to the positive side of the AO. So we're mainly looking at a significant time period of a negative AO according to this model. The GFS AO forecast, again, showing a negative tendency to the AO. And look how far this thing drops off negative, below -5 magnitude by the 17th and 18th of December. Now, I don't necessarily trust the deterministic or operational models very often when it comes to these teleconnections forecasts. And the main reason is, they change so frequently. They're so erratic and chaotic. This is the GFS ensemble forecasting system with 30 perturbed members of this particular ensemble run. The ensemble mean is a green line showing, again, a very sharply negative AO throughout the entire period, right on through 18 December. What about the NAO, North Atlantic Oscillation forecast? Positive NAO phase here on the left. And when you get a positive NAO phase, you typically get milder conditions across the mid-latitudes, whether we're talking the eastern US or whether we're talking Europe. Generally milder conditions with a positive NAO phase. You get lower pressure at the higher latitudes. You got this high pressure down here to the south, and you got a stronger Icelandic low with a positive NAO. And then you get a stronger Azores high to the south. So what this does is it increases your height or pressure gradient between the Azores high and the Icelandic low, and that causes an acceleration of the wind speeds at 30,000 feet above the ground at the jet stream level. So we have a stronger west to east jet stream with a positive NAO phase, okay? Negative NAO phase here on the right is a different story. We have strong upper level ridging poking its way north in the North Atlantic into Greenland. And then we have more of a weaker westerly wind belt, weaker jet stream. When the jet stream becomes weaker, this pressure or height gradient weakens, you get more of a wavy nature to the jet stream. See this? See how we're changing from more of a west to east during the positive phase, west to east jet during positive NAO phase versus a negative NAO phase where we have more waviness, deeper troughs, more highly amplified ridges, and you get colder and snowier conditions across the East Coast, cold and dry across parts of Northern Europe. And the pattern basically flips. So warmer over the Arctic and higher latitudes, colder in the mid-latitudes with a negative NAO phase. So let's take a look at the forecast for the NAO phase. Wow. European model, negative, right on through 13 December. In fact, The forecast for the NAO is so negative. This is the lowest values forecasted since December of 2010. And that was a pretty cold month in the eastern US. Looking at the European EPS NAO 50 perturb member forecast, look at the green line here, the ensemble mean, negative. And we're talking deeply negative by the 6th of December, down to a -4 magnitude, and it doesn't really rise very much. All the way through the 17th of December, sharply negative. European EPS, now we're at 50 perturb members, out 46 days. Similar to the AO, look at this thing. Look where this thing drops to, all the way down to that -4 magnitude around the 6th of December. And it doesn't, it finally starts climbing up after the winter solstice as we get closer to the Christmas holiday. But generally around the 26th of December, it becomes neutral. One thing I want to point out, and this is literally from Kosin and Uccellini, the Northeast Snowstorms, great 2-volume set. East Coast winter storm development, Kosin and Uccellini found that East Coast winter storm development is favored generally when the negative NAO, this negative NAO actually eases up, gets closer to neutral conditions. So if we were looking at this model in particular, the EPS out to 46 days, you notice where it's easing up at right here. Okay, see how it's climbing and that strongly negative NAOs, starting to ease a little bit. Those heights aren't literally as high as they once were. They're starting to lower a little bit. So our NAO is getting closer to the neutral territory. This is the area, if this model verifies, this would be the area I'd be most concerned about, like significant East Coast winter storms right in this zone here, between the 21st and the 26th. All right, so yeah, I am dreaming of a white Christmas, but you know what? I don't normally get to say that and actually see data that might actually support it. So I'm a little bit excited about it. All right, the GFS operational or deterministic model showing that negative NAO as well, right on through the 19th of December. And then the GEFS V12 NAO 30 perturb member forecast. Ensemble mean, the green line here, well, sharply negative on the GEFS V12 for the NAO. And then it eases a slightly negative. So now if we were going to look at maybe potential for a favorable situation for a major East Coast winter storm, according to the GEFS V12, it would be here. 16th to the 18th, somewhere in there. Now let's take a look at the PNA forecast, the Pacific North American forecast. So the big difference with PNA, yes, PNA can be both positive and negative. PNA can actually be neutral too. Here's the thing, with a positive PNA, this increases chances of below normal temperatures across the eastern US when it's positive. With generally below normal temps east, above normal temps in the west. Because what you have with a positive PNA is a western upper level ridge, and then you have an eastern US trough. With a negative PNA, which we're seeing right now, that increases chances for milder or above normal temperatures across the eastern US. And with a negative PNA, it's the opposite of the positive PNA. So now with a negative PNA, what do we get? We get these below average heights, and these troughs setting up over the western US, below average temperatures and heights, cooler, unsettled temperatures, and weather general out in the western US with a negative PNA. And then downstream of that, you get the height rises and a ridge. Typically that southeast ridge just sits there for days on end and just keeps the coldest air back to the northwest. Now let's take a look at the forecast. PNA forecast European. You see we're here at 2 December, sharply negative right now, but it is going to start rising a little bit according to this model. By the 5th of December, it's close to neutral, but then it drops back negative again. We look at the European EPS PNA 50 perturb member forecast. This one's out 15 days, out to the 17th of December. We do have sharply negative PNA initially here, the far left, on the 2nd of December, climbing close to neutral there around the 4th to 5th of December, but then dropping back negative again by the 7th of December, and then working its way closer to neutral by about the 13th to the 14th of December. European EPS PNA 50 perturb members, out, 46 days now to 16 January. The green line being that ensemble mean, or the average of all the model members of the run. Very negative initially for the PNA, working its way closer to neutral conditions, but then back down to negative. So we have this high confidence through at least the 7th of December that the PNA, for pretty much all the models, that is sharply negative at the start, comes up closer to neutral, but then drops back negative again. and before it finally looks more neutral, I would say, here according to the European EPS, a 46-day forecast with 50 perturbed members from the 12th to the 13th of December right on into 16 January, fairly neutral. NOAA, the GFS operational or deterministic model of P&A forecast, which again sharply negative and very similar, comes up close to neutral, but then drops back negative again. Then it remains negative throughout the entire period according to the GFS 12Z run from today. Negative all the way through the 19th of December. Finally, the NOAA GEFS V12 showing sharply negative, rising close to neutral, back down negative, and then coming up again closer to neutral by the 12th to the 14th of December for sure is what the forecast is from the GEFS V12 for the P&A. Now let's take a look at one last teleconnection, the Eastern Pacific Oscillation, EPO. With a negative EPO, you typically see a very strong ridge of high pressure and warm air aloft over the northeastern Pacific into Alaska. If this ridge builds far enough to the north, you get the Siberian air, that cross-polar flow that gets set up. In general, if this ridge really amplifies, which we've already seen in late November, where many portions east of the Mississippi River were setting record cold temperatures. So this is generally what's favored with a negative EPO. You got the Arctic high, you got colder air spilling southward, Arctic air coming down southward from Canada to the U.S. You also have that jet stream is more meridional or more wavy in nature. And with a positive EPO here on the right, we have a reverse of the pressure patterns in the northeastern Pacific. So now, with a positive EPO, we have a stronger Aleutian low pressure in the northeastern Pacific instead of this upper level high. And we also have milder Pacific air flooding the continent, the North American continent, from the west coast to the east coast of the continent. Coldest air remains well up over the polar areas, the North Pole area with a positive EPO. So let's take a look at the forecast. European forecast for the EPO showing a strongly negative situation right on through the 6th, the 7th of December, then it climbs back up to slightly positive, then approaches neutral after 11 December. The European EPO 50 perturbed member forecast out 15 days to the 17th of December, showing a sharply negative EPO, followed by a return to more neutral conditions 7 to 9 of December, then dropping back down to negative again. The European EPO 50 perturbed members out 46 days, out to 16 January, showing sharply negative EPO, rising up to near neutral conditions by the 9th of December, dropping back negative, however, 9 right on to about Christmas Day, 25 December, before becoming neutral, and then going slightly positive as we go into early January. And then the GFS operational run from 12Z today shows a sharply negative EPO, climbing close to neutral by the time we get to the 8th of December, then slightly positive, right on to 11 December before dropping back negative and then dropping negative again. And then finally, the NOAA GEFS V12 EPO 30 perturbed member forecast showing a sharply negative EPO, climbing all the way up close to neutral conditions by the 7th of December and remaining neutral for the most part through 11 December before dropping back negative. All right, so that's all the teleconnections forecast. I'll sum this thing up nicely at the end, what all those forecasts could potentially mean for our weather. Here is the stratospheric polar vortex forecast. This is the 12Z GFS run from today to December 2022. This was 12Z as of today, the 2nd of December 2022, showing again more of an elongated or stretched out polar vortex. And by the time we get to next Friday, the graphic here on the right, this is the forecast for next Friday, which would be the 9th of December. We still see a highly chaotic polar vortex. It's stretched out. It almost looks like we see two lobes here, one over eastern North America and the other one over on the Eurasian side. We also do notice this yellow coloring here. Now this is indicative of what's known as stratospheric warming or warming temperatures within that second layer of the atmosphere known as the stratosphere. So it'll be interesting to see what this does over time. Where does this warming take place in the stratosphere? At what location does it occur? Because that could have a huge impact on the later behavior of that polar vortex later in the winter. Looking at the European polar vortex forecast, this is today here on the left again, just showing that we have one specific lobe of the polar vortex over central Canada, and then there's a secondary lobe over on the Eurasian or the Siberian side. Generally looks weaker. What we have over here on the right is your forecast, the European forecast for the polar vortex. By the way, these are heights. So these are heights here, but generally those higher heights are associated with warmer temperatures and the lower heights with colder temperatures. So generally what we have here is lower heights, generally stretching out, being more elongated on the Eurasian side of things of the globe by the 9th of December. And we have these above normal heights here across, just north of Greenland in association with that tropospheric negative NAO pattern. And so general elongated look continues on the European model as well, right on through the 9th of December. What about the GFS Ensemble, the GEFS forecast? Current conditions here as of 12Z today, 2 December on the left, showing these are temperatures. Yep, these are Ensemble mean temperatures and anomalies in degrees Celsius, right on up at 10 millibar level, well above the ground. Generally what we're looking at here is colder stratospheric temperatures in green, warmer stratospheric temperatures in orange. What happens here by next Friday? This is interesting. See this brown coloring here? We have significant warming occurring in this area. Look how it was green, how it's green today and much colder the temperatures in the stratosphere. But by next Friday, look at how much more warming occurs in the stratosphere, generally on that Eurasian or Siberia side of the globe. This looks very elongated. These are isotherms or lines of equal temperature in the stratosphere, but I just like to look at the patterns here, and it looks very elongated and generally weak. All right, so now let's take a look at the overall 500 millibar geopotential heights and the anomalies in meters. First thing we're going to do is we're going to look at a 4-panel here for the forecast at the 500 millibar level. This is a European EPS. All right, and the upper left-hand graphic here represents the forecast for this Sunday, the 4th of December. The upper right-hand graphic is the forecast for Tuesday, the 6th of December. Bottom left is the forecast for next Saturday, the 10th of December. And the bottom right graphic is the forecast at 500 millibars per the EPS for next Tuesday, the following Tuesday at 13 December. All right, so what's going on here? By the way, when you see these maroon colors or these brown colors, or even these whiter light brown colors, that's indicative of upper level ridges. Upper level ridges associated with dry and generally milder conditions, whereas the purples, the greens, the blues are associated with upper level troughs. Upper level troughs are associated with cold temperatures, unsettled weather conditions. So generally what we got going on here for this Sunday, what's happening? We do see a strong upper level ridge that's building into the Gulf of Alaska, extending northward into Alaska itself. Beneath that ridge, you do see a closed low just off the west coast of Northern California. And then downstream of that, downstream of this pretty extensive ridge in Alaska, we see downstream troughing and this cold vortex represented by the purple coloring here over central Canada. And so we have a deeply closed low here over central Canada with very cold temperatures towards its center. And then further downstream from that, we're starting to see the semblance of a strengthening or building upper level ridge on the North Atlantic side associated with a negative North Atlantic oscillation, negative NAO, working its way with highest heights generally to the east of Greenland. Now, meanwhile, in the lower 48, we see an upper level high height center, 588 decameter high height center over the western Gulf of Mexico. And we do have, a bit of milder temperatures. It looks mainly zonal, the jet stream here, across the southern U.S. into the mid-Atlantic on Sunday. Moving ahead now, the upper right, the forecast. What's going to happen with time is we're going to see this ridge. It's going to weaken somewhat over the Gulf of Alaska. We're going to see this particular trough off the coast of Northern California, Oregon, drop further south. And so we have a negative Pacific North American pattern, that negative PNA pattern associated with this troughing of the western U.S. And then as we look over central Canada, we still have very cold temperatures at 500 millibars, very low heights, anomalously low heights, is close to upper level low, still parked over central Canada by next Tuesday, the 6th of December. So we have this cold vortex. We have the trough out in the western U.S. associated with a negative PNA, and then we have this ridging that extends from the Gulf of Mexico right on up the eastern seaboard to New England. And then look at this thing on Tuesday, the 6th of December. Look how strongly negative the NAO becomes. Look how high these heights are. This anomalously high height center into the southeastern portions of Greenland by Tuesday. Bottom left is the forecast. Let's move ahead. This forecast is for, again, next Saturday, the 10th of December. We still have troughing over Western Canada down to the northwestern U.S. And that's associated, again, with that pesky negative PNA. All right? And then downstream of that, we have this ridging over the eastern U.S. that persists per the 12Z model runs today on the European for next Saturday, the 10th of December. And then this very strong negative NAO is still sitting there. By this point, next Saturday, the 10th of December, the center of the highest heights are going to be generally over Greenland itself, but starting to work their way further to the west. And then here in the bottom right, showing you the forecast for this would be Tuesday, the 13th of December, showing the upper level ridging, generally continuing into parts of the eastern Aleutian Islands and also western Alaska over the Northeast Pacific. This troughing that you saw here next Saturday, the 10th of December, the European EPS showing it weakening. You still see a remnant of some troughing across the Pacific Northwest by Tuesday, the 13th of December. But look what's happening in the east now. See this? Notice how we went from the orange coloring here, the ridging over the east, to a trough in bluer, lower than normal height anomalies now. That's associated again with this negative NAO. And by this point in time, by the 13th of December, for the latest forecast guidance, now this is subject to change, guys, but generally we're looking at the highest heights to the west of Greenland by the 13th of December. We're switching to a west-based NAO by the 13th of December. Initially starting out as an east-based NAO. East-based NAO is going to keep the trough further to the northwest. It's going to keep that ridging in place along the east coast. But a west-based NAO, when those higher heights shift west to Greenland and retrograde more to the west, you're going to get a pattern change for the mid-Atlantic, the general east coast up to New England. Now let's look at the GEFS model, the Ensemble here. Upper left, forecast for this Sunday, the 4th of December. Negative PNA continues. Closed upper level low, very similar to the EPS, very similar. We see that strong upper level ridging above this closed low. And almost like a Rex block type pattern with a high over a lower height center. And then you see downstream of that with this cold polar vortex again, the cold vortex sitting over Hudson Bay, the strong upper level high still established there over the Gulf of Mexico this Sunday, more of a west to east flow. This is more that transitional day across the mid-Atlantic on Sunday. It'll be fairly cold on Sunday, but then we'll start transitioning back to milder conditions as we move to next Tuesday. Here in the upper right, you'll see that ridge building slightly up the eastern seaboard again. And then we have this strong negative NAO east-based situation, the negative, strong east-based negative NAO, highest heights to the east of Greenland per the GEFS model by next Tuesday. Still have that negative PNA though, it's still dragging the heights down across California, and that's allowing this ridge to still hold on. Forecast here bottom left for, this would be the GEFS forecast for Saturday the 10th of December. This ridge is going to, believe it or not, this ridge is going to briefly build further up in latitude, further northward. So it's going to be fairly mild again. We'll see a brief mild period across the east because this trough across the western U.S. has dug a little deeper, and that results that negative PNA is holding on out there. And then we see the overall upper level ridging into Greenland, southeastern Greenland by the 10th of December, and then finally the GEFS here at the bottom right showing the forecast for the 13th of December. We got that persistent upper level ridging, higher heights across the Northeast Pacific, south of the Aleutians. We've got, now look at this now though, a near neutral PNA now. See this? By the 13th of December. What did the Europeans show us? Near neutral PNA, I would say. More of a flatter west to east zonal look to the jet stream. Weakening troughing out in the west. Deepening troughing along the eastern seaboard. And now look at this. The GEFS model showing a similar outcome. Near neutral PNA. That's going to flatten out this trough, all right? And then we're going to see a much lower height anomaly, greater height anomalies, which are lower here across the mid-Atlantic by Tuesday the 13th of December. And now, look at this. Both models showing it. The European EPS for 13 December and then the GEFS here 13 December showing the highest height rises or highest heights west of Greenland, associated with now a west-based negative NAO. All right, that's going to allow this trough to set up further east, colder temperatures to occur across the eastern U.S. Now let's continue on, just looking at a couple more longer range ensembles. This is a European EPS. And by the way, both of these are for the 17th of December. In general, I just wanted to show you what we got going on. Pattern-wise is looking good if you like winter weather across the eastern U.S. Because even though these heights are starting to basically, this ridge is starting to weaken a little bit, the heights are lowering slightly, you're still getting the blocking over the top. You still have the highest heights west of Greenland, associated with that west-based negative NAO. You have higher heights there off the North American coast, the west coast of North America, and you generally are favoring that troughing still in the same location over the east coast by the 17th of December. And you can look at both of these graphics and they're generally the same. All right, so now that we've talked about all these factors, and I love this stuff because, you know, it's like figuring out a puzzle, right? Which one of these teleconnections is going to like just totally dominate the other ones? What about the polar vortex? Let's just get into these final thoughts tonight. We're looking at the MJO basically rotating into the null phase. The majority of the models show this, right on through the 16th of December. Very minimal impacts expected of the U.S. weather. Now, could this change? Absolutely, but I'm just going strictly off of what I'm seeing today on the 2nd of December per the model guidance. The La Nina conditions continue across the equatorial eastern and central Pacific. In fact, we're seeing 1.04 degrees Celsius below normal water temps in that Nino 3.4 region. That's going to favor ridging and milder temps across the southeastern U.S. up to the mid-Atlantic. Now, why is that important? Because with the La Nina conditions, that destructively interferes with the negative NAO pressure pattern. There's two teleconnection features here that are really going to offset or work against the negative NAO, negative AO pattern. I'll get to that soon. Sea surface temperature anomalies. Temperatures have definitely cooled at the higher latitudes north of 30 degrees latitude in the northern hemisphere over the North Pacific, North Atlantic. Since I did that video 2 weeks ago, the other teleconnections discussion video on the 18th of November, we have greater mixing of that wave action, increased storm activity. Models are indicating that sharply negative AO phase in December. And a negative phase of the AO favors below normal temps across the east U.S. with a more meridional jet stream, weaker westerly winds. Models are also indicating that strongly negative NAO phase in December. In fact, the strongest since December 2010. As far as the month of December goes, it's the strongestly forecasted negative NAO since 2010. Negative phase favors below normal temps across the eastern U.S. with a more meridional jet stream, again, the weaker westerly winds. And again, the main thing with a negative NAO, though, it depends on where the highest heights set up, east versus west-based NAO. East-based NAO has the highest heights east of Greenland, coldest temps are further west. And then the west-based NAO, a negative NAO, has the coldest temps and the troughing more along the east coast. Okay, we have to really wait until this NAO, this upper level ridge, really retrogrades or moves from east to west, further back to the west of Greenland. We have to wait for that because you have this strong ridge over the Gulf of Mexico. You have this negative PNA. You have a La Nina, which typically favors troughing out over the northwest and northern plains and ridging in the east. So we have some interesting things going on for sure. Now, models are generally indicating a negative PNA phase, trending neutral by mid-December. Now that's important. If the PNA were to trend towards neutral conditions by mid-December, that flattens, that upper level trough would be more flat. It wouldn't be dug in. We'd have more west-east flow across the western U.S. Okay. Below normal heights with a negative PNA, troughing and colder temps occur across the western U.S. You get higher than normal heights and ridging, milder temps across the east in the short term over the next, say, 7 to 9 days. Now, a pattern reversal is favored around mid-December with colder temps across the eastern U.S. Now, what does a negative PNA do? It destructively interferes with that negative NAO pressure pattern. All right, so La Nina destructively interferes with a negative NAO pressure pattern. Negative PNA does the same. Now, models are indicating a negative to neutral Eastern Pacific Oscillation EPO phase through mid-December. The negative phase would favor that meridional polar front jet, Arctic air, colder temps coming from Canada into the eastern U.S., whereas a neutral EPO favors near average temps across the eastern U.S. And then models are indicating a weakly elongated stratospheric polar vortex in early December. Models are all over the place about the stratospheric polar vortex right now as far as strength. What is it going to do as we move through the month of December? So we'll just keep watching that closely. And that could definitely play into the winter forecast a little bit later on. This does favor colder temperatures when it's more elongated into the central and eastern portions of North America. So here is my final overall assessment for tonight's video, taking everything we talked about into account, and there's a lot. Destructive interference is going to initially occur, and I believe it's going to occur through the 13th of December. All right, we've all been watching the models intently and closely, okay? And it looked like yesterday or even the day before that, the pattern change would occur earlier, around the 8th to the 9th of December, where we get the troughing in the east. That negative NAO would retrograde to the west. And the PNA, the negative PNA would relax a little bit to closer to neutral earlier. Not happening now per the latest model guidance. So what I'm thinking right now is this destructive interference occurs through 13 December. What does that mean, destructive interference? Well, I have a La Nina, which favors southeastern ridging. It favors milder temperatures in the U.S. southeastern area as well as the mid-Atlantic. All right, so that would favor warmer temperatures. Plus, I have that negative PNA, favors warmer temperatures in the east. I have these two going up against a negative AO and a negative east-based NAO right now. So right now, the ridge seems to be very stubborn and seems to have the upper hand due to these particular influences, La Nina plus that negative PNA. But it's not going to be a persistent pattern either through 13 December because we're going to see these troughs that are going to pivot and move through the pattern. These troughs and ridges are going to pass relatively quickly through from west to east through the pattern. So we're going to have a lot of ups and downs in temperatures across the east. That's what I see right now. But as that negative PNA gets closer to neutral by mid-December, and we looked at the PNA forecast, the models for the PNA forecast in the video, when that PNA, the negative PNA gets closer in neutral conditions by mid-December, that trough is going to flatten. It's going to become more zonal west-east flow across the western U.S. And therefore, that PNA is going to have less of an influence on our weather. And then you're also going to have, some additional battles going on between the La Nina, a typical La Nina circulation pattern, versus a strongly west-based negative NAO. Plus, you have the strongly negative AO. All right, so by the middle of the month, that's what you've got right now. La Nina is going to take on, if I were to do like a ring announcement here of like wrestlers or something, in this corner, we have La Nina. And La Nina is going to favor milder temperatures in the eastern U.S., specifically the southeast and mid-Atlantic. And in that corner, I have the west-based negative NAO and the strongly negative AO. So it's literally a battle all the time in the atmosphere of all these competing influences, and what overall things are happening. The atmosphere is trying to reestablish equilibrium is the bottom point. What do we expect by mid-December? Bottom line is an upper level trough becoming established across the eastern U.S. And that's looking, per the latest Ensemble guidance, in very good agreement through early January with that troughing in the east. Below normal temps for the majority of the period. Can we see a brief warm up? Absolutely. The MJO appears to be heading to the null non-impactful phase, but we can monitor it closely for changes. We've got to keep an eye on the MJO and where that convection is occurring in the Pacific, because what happens in the Pacific actually really makes a difference for us in the wintertime. And that strongly west-based negative NAO favors wintry weather along the U.S. East Coast, and there could be multiple lower latitude or more southern storm tracks, which impact the mid-Atlantic in mid to late December. And again, Cosney and Uccellini said it best, when they did their research, storms will more readily move up the East Coast as the negative NAO eases, and we saw that in the model runs, again, for the negative NAO. Let's go back, here. So, the GEFS showing that NAO, that strongly negative NAO easing a little bit by the 16th to the 18th of December, and the European EPS showing it generally easing from the 21st to the 26th of December, somewhere around that Christmas week time period. So if that holds, if that holds and that verifies, that's why I would be expecting, we see some a pretty big storm up the East Coast by that point. All right, that's all I've got tonight, guys. I certainly appreciate your attention and subscribing to the Spot on Weather YouTube channel. That's why it takes me a while to put these things together, believe me. And I do my research and I really have to dig in to figure out, from all the weather charts I look at and, the teleconnections forecast and kind of put it all together. It certainly is fun. It's very exhausting also. I'm not going to lie. But hopefully you enjoyed the video. This is, my thoughts as of today, the 2nd of December. Of course, this all could change. But as of right now, that's the way things look. And so hopefully, we'll have some opportunities for a white Christmas this year. We're way out in time still from Christmas, a few weeks out, but patterns looking better in late December across the East if you want wintry weather. All right, that wraps things up tonight, everybody. Until next time, take care and God bless everyone.